Okay, thank you, Katie. So I have the pleasure of talking after both Dina and Jen. So there may be some overlap, and I'm going to try and tie a few things together at the end as well that sort of point to the various things that have been talked about today. Of course, I'll also be talking, since this is practices, about some of the materials or skills that you might have learned in the past couple of days, such as Git and things like that. But I might be pointing out a new skill that I don't think was covered that you should probably train on as well. So on the menu today is kind of a few things from the perspective of me as a data editor and having looked at these things both inside secure environments as well as on the outside. One is data provenance, the idea that you can identify where data comes from. Jen mentioned that in the previous talk that you should be clear about what you're doing to the data as it moves through, and I'll reference that in another sense. But if you're a secondary data user, this also applies to you. So, so you should get what you want, and that information about that is something you need to convey to readers of your research just as much as to your own self a couple of years hence. I'm going to talk about documentation. It's going to be primarily about code documentation, since data provenance is the documentation about the data, but generally referred to as the README, and you should be able to then see that. And finally, you need to think about preserving this. Jen already mentioned this earlier about possibilities to do so as part of your data creation process. I'll reference that. But it's also relevant for the analysis that you do, and those are not the same thing. When I had the comment about, do you actually get credit for data and or code might be separate from the actual paper, and all of those are objects that are in need of preservation in terms of archiving. So one of the hats that I wear is as data editor for the American Economic Association. So what I'm going to talk about, some people might say I might rant about it, is based on our experience over the past year and a half of running reproducibility checks on all, by now, journals of the AA. There's 8 journals that are in scope. And that's currently, we're nearing our 1,000th report during that time frame for about 300 articles. So it's relatively broad spectrum. Part of my job at the AA was to emphasize and revisit the data and code availability policy. I was just asked this morning on Twitter when the first one actually was. That's 2004. So we've been collecting materials over a long time, but there came a realization at some point that not all of those materials were entirely up to standards that we'd like them to adhere to, i.e. they were not all reproducible. And so part of my work has been both to check that they are reproducible, and there's a back and forth with authors on that, but also to, at least from my perspective, to clarify what is it that makes a journal deposit reproducible, and to educate people so that essentially my job of checking at the tail end becomes a lot easier, in theory, trivial or obsolete, because everybody's producing reproducible archives. So some of that has to do with how we formulated the policy. I'm showing you sort of with a few highlights, the text that is there. And there's a few key differences for those who know a bit about the history of this, namely that whereas previously there was this notion of you bring the data or you don't, if you get an exemption. An exemption is when data, for a variety of reasons, cannot be publicly posted. Jen provided lots of examples for that. The other flip side of that is, for instance, proprietary data, when you've purchased access to data of some kind. And as it turns out, it then becomes often very obscure what data was actually used in the analysis. And we've sort of flipped that around and said, if you can bring it, it's pretty easy to document where the data is. It's not necessarily trivial to document where you got the data from. So those are two different things. But also, if the data is confidential, you are just as able to, or in theory, you are able to document where you got the data from and how somebody else can access that. And so we reformulated this as make it clear that how the access is done, and I am perfectly fine if the data is locked up somewhere, just as long as you as the author are not the sole gatekeeper. That's sort of the only exception that we make to this rule, is that if others can access it and you're not the gatekeeper, we're fine with it. And there are, I'll provide some examples at the end, because at the end I will end with an actual rant that was triggered by a news article this morning. We'll talk a bit about what that actually means when data is confidential, but when hundreds or even thousands of researchers can access that, right? And some of the other stuff around that is that we are looking at how this works, how we're checking these things prior to acceptance. That was one key cudgel that was given to me as the data editor, is that I determine whether or not you get to publish or not. I don't get to revisit the article, but I do get to certify that your materials are actually acceptable according to standards that we've posted. So what we do is we preemptively improve those code archives. We get pre-publication versions of them. They might already be in the public domain, but that's irrelevant for us. We check whether they actually work. So I have a group of about 20 undergraduates working with me on this that run through this code and actually check it. We also check that wherever you're putting the data, and 95% will go into our journal-related archive, but they can be elsewhere, are accessible and that they're transparent and well documented. And one of the key things that has turned out to be a big hurdle is better provenance tracking. Ideally, leave code and data where it is. If you have already archived it, we're not going to ask you to deposit it again, but you need to document where you got it from. And if you're not depositing because it's confidential, you need to do that. And if you are depositing it because it's not confidential, because it's in the public domain, we still want to know where you got it from. Okay. Now, this is not a panacea. It doesn't solve all the reproducibility or replicability problems in sciences. For one, we are very firmly at the left of this spectrum, right? This is pure computational reproducibility. We're not going to go out and collect the data again. Sometimes accessing the data is equivalent to collecting the data again, so there is a bit of give on that, but we're firmly just checking that the code runs. We are not checking 1,000 lines of code with a couple of undergrads to verify that you are actually using the OLS regression that you said you use, or the error correction, or the fixed effect estimator, or whatever it is that you're using. We're not checking that. You've got bugs in the code and they generate the wrong numbers in the table. As long as the code reproduces those wrong numbers, you pass by our screen. But you're going to post those materials and somebody else will discover that. And then there's a whole process about how we can fix that after that that we can get into at the end of the conversation. So, data provenance. And it helps to sort of think about this as a very simple data flow that you can think of, right? So you have typically you've got to focus on analysis data that is the input to your analysis programs and that generates the tables in the paper. And traditionally, that's all that replication archives were supposed to contain, right? We've expanded that to say, we also want your data cleaning programs and we want the input data if we can, right? But key to that is also, I'm not just going to take your data that you're giving me at face value. You said you have something that's called the CPS. I want to know where you got it from. And I might actually check whether you got it from there. And that's just as important for the confidential data. Now, the key reason that's a problem is because at least economists are really poor at describing where they got the data from. So if you tell me, yeah, I got the data from the Bureau of Economic Analysis, GDP data. Well, I want to know where you got it from the BEA, which revision it is, because as you learn very quickly, there's 3 revisions to each GDP estimate, and there might be wholesale revisions, and you might have used that one. And you might not have gotten it from the BEA, you might have gotten it from an alternate source that repackages the BEA data. We want to know, right? And so just stating that kind of information is not sufficient, but historically, that's all that one got. Same goes for the current population survey. You can download it from IPMS, you can download it from the Census Bureau, you can download it from the NBER, you can download it from a couple of sources, you can even download it from a different paper that has used it and that was not subject to our kind of review. So where did you get it from is really important. So let me bring an analogy. Would you buy a car from this guy, right? I might. Maybe the color of his suit is not something that that influences me, but I'd like to know, does that person have a good track record? Do his cars flop the moment they turn the next corner, or are they reliable for the next 10 years? Where does the car come from? What do we know about the car? Can I get a Carfax report? Something like that. And the analogy for data is that data ultimately is just a bunch of bytes. And you give me this file, what am I supposed to do with that? What worth does it have? You're saying this produces the tables in your paper, but I need to know more about that bunch of bytes. And that is really relevant even in the current time, because a few of you might remember the Florida snafu about reorganizing the data so that it shows a decline, when in fact it was not that scenario, right? So understanding what the data is, where it comes from, how to present it, how to process it, etc., is really important because it has serious implications. And so for data, all those same questions are important as well. I got data from some back alley CPS provider. If those exist, maybe I don't trust it. Maybe that's not the original data. Maybe that's not right. I got it from IPAMS. I'm pretty certain it's pretty good, but I want to know when and how you got it, because they actually make improvements to the data and things like that. So where do they come from? What do I know about the data? Data about data, that's called metadata. And you might not think it, but you use metadata every day, because that bunch of bytes, if I tell you it's an XLSX extension, now your operating system knows to interpret it as an Excel file, and I call it stock market, now I have a bit of metadata about it. Still not perfect, but at least I now know how to interpret these bytes into something that is starting to take on some meaning. If you then tell me this is actually S&P 500 Excel file, now I might actually think that maybe there's something there to it. Maybe this is reasonable. If you tell me you downloaded from Fred at the St. Louis Fred archive, that's a reputable archive, I believe you, right? And you can even cite it because Fred gives you a citation. So now I have a complete provenance chain. I know what it is, what it's supposed to represent, where you got it from, a reputable data provider. I've got a chain. We're all set, right? Well, unfortunately, that's not sufficient. So let me introduce you to licensing. These are S&P 500 data. They're actually commercial data. They're proprietary data. And so as it turns out, you would need to specify that you did not give me that file. And we've told authors to remove these kinds of files because they're subject to copyright and are property of Standard & Poor's. Right? And the fact that they're presented at Fred, just because you can see them, does not give you permission to republish them as part of a replication archive. And so one part of this, it's called the data availability statement, tells you what the data file is, where to get it, and potentially any restrictions or conditions on how to get it again, right? So you're not going to get it from me, but you can always get it from Fred. As it turns out, not always exactly, because they only keep the last 10 years. So if you're doing 20 years of stock market analysis, you can't give me the file that you might have collected over time from Fred or from some other source, right? And the data citation is the sort of summary of that information that attributes the file to the proper source.
Hey, Lars, there's a question in the chat. Can I ask?
Yeah.
Ruben asked, should we trust an Excel file downloaded from a reputable source, for example, S&P 500, instead of downloading the numbers ourselves?
Well, that's the part about the data provenance statement. If you think it comes from a reputable source, and there's other information about what are reputable sources, then you can stop there and go on. We do that all the time, right? We read information on news sites, etc., and we classify them into reputable sites. And what my cousin posts on Facebook, I'm not going to classify as reputable, even though it might be the exact same information, so I might not trust them, right? But the idea of provenance is that you can actually go and check, right? So you got this file from a replication archive, but you're not certain about that. Go back and check, re-download it, rerun the code with the file we downloaded. And we do that as part of our checks sometimes, right? So we will use both the file that the author provided, if they were allowed to give it to us, and we will re-download it and see if that gives the same result. Okay. And Dina mentioned this morning about attribution, and part of this is about data attribution. So it's not just about, or rather attribution ranges from all the way the just starting RA who's helped on a project, all the way to a data creator. We mentioned the possibility that people are just responsible for creating data, and that's what institutions sometimes do as well. And so credit and attribution are embedded within the data citation principles that also say that this is important, and in particular, it's evidence. And we're taught early on to attribute the information that we do to the person who first generated it or came up with it or developed it or etc. as a measure of academic honesty and academic provenance, right? I'm not going to claim that I invented monetary policy when somebody else did it. We do that by citations. Well, data citations are somewhat similar. As it turns out, they're hard as well. We're not used to it. We haven't been trained on it, and we tend to ignore it. I got data from here. So the funniest data provenance descriptions we get are the ones where they got data from 2 institutions and 2 authors. They'll cite the authors, they won't cite the institutions in the same line. And yet the data is equivalent, right? So at the AA, we check every manuscript at present as it comes in and look at what data sets are used. And you'd be surprised how often we find data sets that the authors don't actually acknowledge using, but when you look at the code, they actually use. Are they cited? And is there additional information on how to access them? In its simplest case, it gives you a URL, you click on it, you got the data, you're done, right? The most complicated case, there's a 3-year application process for which you need to become a Norwegian citizen and move to Norway in order to access the data. The 2 are equivalent descriptions of access. One is just a bit harder than the other one, although at present that might not be a bad choice. We need to know whether the information that you did provide actually is relevant, right? Is there license data? Should the author provide the data? The author said, I can't give you the data. We've gone and checked and responded, yes, you can. Or sometimes the author is not allowed to provide the data. Authors have said, here's some data. I got this from Compustat. And we'll tell them, you're not allowed. You need to get permission. You can actually get permission. So if you ask, you might actually get it. And sometimes we actually talk to the data providers themselves and have them change their mind. So one particular academic data publisher, Economic Policy Uncertainty, currently pretty relevant if you're in economics, publishes the Economic Policy Uncertainty Index, right? And when we looked at it, it said copyright. That suggests that barring any other permission, you're not allowed to repost the data because these guys are creating the data, it's their data, all rights reserved, you're not allowed to distribute this. But we actually contacted them and they changed their policy to a CC BY license because they said our whole point is making this data available. The other academic data publisher on the paper that we contacted said, nope, people can get it from me. They should come to me. I'm not making it available for redistribution. So you get both answers, but they're relevant. So you need to know your data rights, right? Rights to use the data don't come automatically when you browse a website, you purchase the data, or you sign a data use agreement. Read the data use agreement. If you created the data, you might be able to use it, but that depends on your consent statement that you embedded within it that we just talked about in the previous talk. Do you have IRB approval? Do you have the right lab experiments where the participants sign some waiver or something like that? If you didn't put the right language in, you might not have rights to repurpose that or to distribute the data, right? If you create the data from scratch, you collect it on something that is observable in nature or something like that, then you actually are a copyright owner and you get to decide. But the key thing is, these are not automatic. And you sometimes get the rights to decide, to develop a policy, and sometimes you need to respect the policy. And that's not trivial. Restricted access data is one particular example where if you're using it or you are party to the creators who use it collected through a survey, then well, if I can't download it, I can't cite it, right? Not right. One example I like to do is a German restricted access data center that has actually gone as far as assigning DOIs, digital object identifiers, permanent identifiers to data that you cannot download. You can download the documentation, but you cannot download these data. But you actually have to go through, and there's a data access description that you can pop into your article to go to their website, apply for it, go to their on-site use, and you can access that. And hundreds of users do, right? So it's worthwhile to just go back to what is actually a citation. So in economics, we mostly use the Chicago manual style, and I highlighted here what they essentially call, what is a citation, not a data citation. So source citations, their whole goal is to lead a reader directly to the source, okay? And it's right there in the very first paragraph where they talk about citations. If they are not readily available, whatever that means, it should still allow you to positively identify them regardless of whether they are published or unpublished in printed or electronic form. That's possible, right? So ICPSR thinks about electronic data and gives you information about what constitutes those unique identifiers. And ideally, online information has, as in the German case, a digital object identifier. But these are citable archives, right? They have identifiers, they have a location. You can, with that proper information, walk up to the rack and pull out a tape from 50 years ago. That is a citation. So you don't have to have a URL. You don't need to be able to simply download it in order to cite it, right? And if you look into historical archives, you will see citations that reference the box, the folder within the box, the particular archive where it's at, etc. So how do we translate that into data citations? So here's some practical advice. On the left is the list of items that ICPSR suggests a data citation have, right? Author, title, distributor, date, version, and a persistent identifier, right? That box in the archive has a persistent identifier. It's box 8, folder 9, right? Now, if you lose the paper that's in that, that might compromise the archive, but that's a different question, right? The Dow Jones question has all those elements, almost. The persistent identifier is the Fred URL. It's not entirely persistent, but it's going to be there for a while. The date is simply the date I downloaded. We can't do any better than that, so that's what we'll put in there. The distributor, it's not the S&P 500, it's not Standard & Poor's, we got it from Fred. So that's relevant because we didn't get it directly from the source, we got it from a distributor, right? It has a name, it's called the S&P 500, but the author is not S&P 500, nor is it Fred, it's the S&P Dow Jones Index, and Fred shows it like that, right? So that confidential data has an author, the Institute for Employment Research has a name, Establishment History Panel. You can access it through their research data center. It has a DUI as a persistent identifier, and you accessed it on a particular date, right? That information is sufficient to uniquely identify where that data came from. And I can go back and get ideally the same data, right? That's a data citation, and it attributes the input to my statistical analysis back to the source where it should be cited. So you can do that for a few things, and we check them. Because if you actually click on a few of these things, so when you finally cited the World Values Survey, we might actually see that if you gave us the data, you actually shouldn't, right? So the key thing here is provide the data citations and a data availability statement in order to maintain data provenance in a clear and established way. Any data can be cited, even if you can't download it, as long as you can describe it in such a way that you and other people can find it again. And any data that you access can have that access be described. But it's important to consider, for instance, say you are at a survey institute or you are at the research institute that collected the survey data. Your access might not be the same as somebody else who wants to get access to the data. So you need to be aware of how to describe to others how they got the access. If your access was, I downloaded it from the shared drive, that doesn't work for people who first need to go through an application process. Where is your institution's application process? Did you define one? Did you define those data sharing rules that Jen mentioned earlier about how you define the various data handlers throughout the process? They need to have a process in order to request the data, right? And distinguish between sharing and publishing, right? It might be legitimate to share with your co-author because you sign and you're responsible for him. It might not be legit to publish it on a website as part of a replication package, and you need to know the difference, okay? Okay, so what about your code? What can we do there? We've talked about provenance of data. So where did the data come from? Now we want to talk about how can I figure out that your tables actually derive from that data that you now told me you downloaded from a particular site. So how is code documented? Seems trivial, but as I can tell you from having looked at 1,000 iterations of this, is not. So for yourself, if you're just going to be developing your code, and I'll get to the difference between developing and publishing in a moment, what are you doing on, say, lines 30 to 45? Right? You've edited away, you've hacked away at it, etc. Do you know what you did there when you come back to this a month from now or 3 years from now? And whatever it is that you're doing, are you doing something that's also outside of the code? Right? You have to set up, you have to load the data, etc. that are there. Put as much in the code as you can, because that's your documentation for yourself. But you also have an audience, and that audience is not just people who will read the finished product. You're presenting this to your thesis advisor, your boss, your coworker who's going to take this over because you really don't like this project and you've been trying to convince everybody that somebody else should take it. It only gets taken over if you can explain to others what they need to do. That's an audience. And then we're not talking about reproducibility externally, we're talking within a working group yet. And there might be conventions, habits, culture within institutions that facilitate that. But at least in the social sciences, we tend to be a loose collective of folks who kind of work together with co-authors that change over time, et cetera. And so having to work with different multiple co-authors that have different cultures is something that you need to think about as well. When you ultimately publish this, it needs to be understandable by people who read it 10 years from now who don't know who you are and who have no way of asking you. Right? So think of some poor coding practices that produce no meaningful output. Right? You know that you're going to pick that number on line 775 of the log file and pop it into your table. That's not good enough. You're going to forget that and the next person won't know it. Right? Bugs in the code that you kind of fixed, but you never saved the code file. That's going to bug you again a year from now because you'll forget what the bug fix was. Right? Putting stuff out there that is not well explained, that manipulates data in unclean ways that are not reproducible. Here's a SAS program that does a few things. If you disentangle it, you'll find that my stuff.sas isn't particularly informative. If you look at it, this actually destroys the original data. So you didn't separately treat it, analysis data and input data. There's no portability. And in particular, if you do this and you run it again, you're not going to get the same result because you destroy the original data, right? All of a sudden you get log earnings instead of log earnings, etc. It's not portable because you've hard coded that particular directory path to your current laptop. And while this might seem obvious for a normal regression, if you're doing something more complicated, what is it that we're doing and why are we doing that? Right? So a few thoughts are, again, thinking first and foremost about yourself. Your laptop is going to die next week. What are you going to do about it? Your next laptop might not look the same. Maybe your boss has switched to running on a Mac while you're a Windows person. So all of your hard drive paths are going to be obsolete and won't work anymore. And 10 years down the road, you don't even know if you're not running this on some iPad, right? And don't assume that you will remember what seems obvious now. Put it out there. File structure, I don't know whether you looked at this in GitHub. You can version as much as you want, but if the file names don't make any sense to you, there's little point in versioning it because you can't understand what it is that you're versioning. So simple names that sort of evolve over time are not going to be particularly useful. You can improve on that by sort of giving mnemonic names. And ideally, this is sort of my preference, is that you don't even need a separate README, although you should still have one, that identifies what the sequence is in which things need to be run in. You can number them and make it painfully obvious, regardless of what operating software, et cetera, you're using, that these are in a sequence. So these are things that help to identify separating out, preparing the analysis files. In this case, I'm reading data, I'm preparing data, and then I'm analyzing data, is obvious from the way that I structured this. And well, this has only a few programs here and is clearly not the only way to do this. It does make it much simpler to maintain. Finally, you should consider using reusable objects. Reusable here meaning you found a particular way to clean the data and you're going to get an update to the data again. Maybe think about not hard coding the input file, not hard coding what the variable names are, or things like that. Think about reusing in other projects, but also within the same project. You're going to be asked to run some robustness checks. Maybe an endless long list of variations on a particular regression or something like that. My sort of rule is if I've copied it once, that's the limit. If I copy it again, I'm going to create a function and a do file or something like that from it, right? Every programming language has such ability to have reusable code. And even if you're just reusing it within a single project, if you're using a piece of code more than 1 or 2 times, put it into something that is a manageable piece that clearly identifies what it is and goes along with it, right? Once you're at the point where this is going out the door, you might need to redo some of that stuff, right? What's useful when you create code, when you debug code, etc., is not necessarily useful for the replicators. Your paper has 15 tables. Your code outputs 150 tables. I don't think that's particularly useful. It's probably confusing to my RAs. It might even be confusing to you because which is the table that you actually put in the paper. They're all called the same thing, right? So consider pruning your code or having functions that turn off when you're in production mode that don't put out all the robustness checks and all the QA checks and all those kinds of things that you might think about, right? Don't even think about providing instructions on how to manually change parameters, right? You're running 2 different regressions or a simulation that relies on certain parameters, and yes, you have a function. Call it with different parameters. Those are 2 lines in your code that call a function that you've done. Don't tell me to do stuff to the code to then generate 15 different tables or 37 different tables or something like that. And strongly encourage you, write out tables, figures using the packages or the tools that the software has, because it happens on a regular basis. Oh yeah, our code doesn't generate the table that's in the paper. That's from a previous version. We forgot to replace it. Not good. And be clear about all the dependencies that your code has. Stata, R, Python, whatever it is that you're doing, you've got packages that you're using. Be clear about them. You might have them installed on your laptop from 5 years ago, but the next guy running it won't, or won't have the same version. And that does lead occasionally to different results. So be very clear about which versions you're using, and there's tools on each of these, right? The 2 magic Stata lines that I sort of consider as critical, they would make our life so much easier in terms of replication packages, is you're going to give me your do files, and you're going to stick them into a project-specific do path, and that's the line you put into every Stata program you run. And you have one location where your hard drive sits. That's the global base path. And I need to change that one line and everything works just smoothly. It works on Katie's laptop. It works on Alex's laptop. It works on all 3 of my computers, each of which runs a different operating system. It'll work on anything if I just change that one line, right? Some extreme examples from negative examples that I've seen. MATLAB-based simulation, right? There's 10 figures, 4 panels each, 40 figures. And the code, the README literally says that you need to comment out lines in iteration, run the code again, produce something, copy something from, it's a litany of manual tasks that is, if you're being asked to regenerate your paper, you would balk at this, but you're imposing it on the replicator down the road because somehow you wrote the article like that. Not good. Or a Stata variation on this is to copy programs around. This is an ideal scenario to use do files that get pulled into what you do because you're reusing the code all over the place. The ideal setup, the one that provides the greatest transparency and provides a clear path from the data as you got it from the data provenance to the output, is to have one program to prepare the setup, right? You're new to the computer, install all the packages again into a project-specific directory, unpack all the data if it's coming from somewhere else, create any subdirectories that you need to store your outputs in. And then you have a master program that calls all those do files, runs through all the iterations of the parameters that you need to generate that particular paper. And it writes out all the tables and all the figures. And I don't care if you're writing them out as LaTeX or Excel or CSV or whatever formats you can think of. It just needs to be clear what it is that it's writing out. And this is where some of the changes relative to your development model might come in. If you have generated 30 tables, but 15 of those make it into the paper and they're not in the same order, you need to map what the table numbers are in the paper to what I see when I run your code. Right?
Lars, if I may interrupt with a quick question here.
Yeah.
When creating a reproduction package, would you recommend that both the data and the code are shared through a single repository, or is it better to say separate the data on Dataverse and then deposit your code on GitHub?
There is no ideal solution. The standard practice at this point is, if you can provide the data, to provide a single package. But we do moderate that in our practice, for instance, when your data is particularly large. And it breaks down immediately when you're downloading data from other locations where you're not allowed to distribute it. It really is no particular way of doing this. If you're, for instance, keeping your code on GitHub, you are automatically not going to provide a single package, because you're going to run into storage limits on GitHub in terms of data. You're not going to be storing a gigabyte of CPS files for the past 50 years on GitHub. You're going to have to store that somewhere else, right? And so the key aspect here is it has to be clear, right? The ideal, computer scientists always balk at, oh, what do you mean I can't simply download the data as part of the program? And some data you can, and that poses other replication challenges, because if I download today from Fred through their API, I might get different data than you got. So if you should both show me how to download it and provide me the copy that you downloaded, and write a little wraparound that says, if the data is there, don't download it again. Those are kinds of robust programming practices that go beyond just 2 magic lines of doing stuff. But it's perfectly legitimate to have data that you have to first log in and register and consent to terms of use and then download. And then the README contains the instruction, where do I put it, right? And where does my code expect it to be? That needs to be clear as well, right? If you're going to recombine these from various sources, it needs to be very clear, right? And that's what the README is for, right? So you're going to have a full package of all programs, with a small caveat, as Jen pointed out, that sometimes some of the data disclosure code might be at the data provider, but also might be revealing in and of itself. And then you need to ask somebody else to read the README. Do you think you could do this, even without doing anything? And can somebody else run through that code and actually do these things? Because it took you 3 years to come up with this code, but it should take no more than a few hours to rerun this code with somebody who has no information or no knowledge at all about what the stuff is that you did, but can't follow instructions. So I don't think I'd ask my mother to do this, but I almost certainly could ask my daughter to do this, and she's not an economist and she's not trained on this kind of stuff, but she would be able to for a proper archive, right? And that's more or less how we actually reach out to folks when we ourselves cannot replicate it. We reach out to third parties and tell them that's exactly what you do. Here's the stuff that you download. Don't contact the original author. Run through these steps. Do it, right? Okay.
There's one other quick question.
Yeah.
They're wondering if where they could find an example of the ideal setup that you described.
Like I said, there isn't a single ideal setup, but I'll have a few resources at the end. I'll leave you with that.
Thanks.
So now we need to pull it all together. As you said, you need to put the code someplace, etc. And Jen already talked a bit about this, so I'm going to go a bit faster through this. So a full featured repository is sometimes associated with a journal, but you don't have to wait until it's accepted someplace. And I'm pushing very hard for the idea that you should have this in a repository upon submission on your own, not journal specific, and the journal just points to it. So it has to be a reputable archive, but it doesn't need to be associated with a particular journal. So there are a ton of these all over the place, and I don't really care what it is that you use, just use them, right? They need to satisfy certain principles. You need to be able to find them. They need to be accessible, but accessible doesn't mean click and download. Accessible might mean there's an application procedure, right? So you can have fair data without the data being open access data. So there's a difference there. And we can talk about the FAIR principles in some aspects, but one key element of that is that these repositories also provide you with metadata. And so this is one point where you might actually want to deposit data separately, because if you're pulling together 15 data sets into a replication archive, describing what the geographic coverage is or the collection dates, etc., starts to become a bit obscure or confusing. But for every single piece of that, it can be very informative. So you've collected a survey, you know what coverage there is, what time periods are covered, when it was collected, what the universe is, etc. So there's additional metadata that makes this data be usable and reusable by others, right? And so this is an example of the metadata that gets entered on ICPSR. It gets entered when folks deposit for our journals, but anybody can deposit there in the open archives. And then when you browse there, you see all these things as they show up. And there's information there about the creator of the data and the link to the paper. And those don't need to be the same set of authors. And there's a suggested citation. So you have absolutely no reason to not cite the data because it's actually in your face. But behind the scenes is a lot of metadata as well that the machines, that the bots that parse our web are constantly looking at. So the Dublin Core is a set of standards to describe any piece of library related materials. And then you get the more obscure, more modern data sciencey stuff that allows us to find this on Google Dataset search as well, right? So, but you've got your code on GitHub, okay? Is that fine? I don't know, kind of depends on who you are. The trouble is that as you scroll down in GitHub in the settings, there's this little thing there about delete it. So GitHub is just a repository, and it's a repository just as long as you decide it's a repository, because at any point in time, right now, in 5 seconds, you can delete it, and it doesn't take more than that, and it's gone. You might have a local copy and reinstitute it again, but it's gone, right? So what is not an archive, which might be still okay for development purposes or for institutional sharing where you have policies around that and possibly backups and things like that, is all these things that I list on the screen: GitHub, Dropbox, your university website, your Google page. All those things are great for sharing, but they are not archives. They're not meant for preservation. They're all fallible. You stop paying for Dropbox and you drop back down from 2 terabytes to 2 gigabytes and all of your archives are gone 30 days later, right? So that's not a robust solution. But you want to tag certain versions of your code or of your data and create releases, and then use those releases as part of your development process, right? So define whatever is a critical moment. I create a release every time that I communicate externally to our group on something, right? You're showing it to your thesis advisor, it's a release of your code. You're submitting to a journal, it's a release of your code. You're through the first R&R, that's a release of your code. Your final R&R and the sending out to the data editor, each of those are releases that are really easy to do. But now that you've got releases, you can practice how to archive, and I've provided here links that go to the Open ICPSR sandbox, there's a Zenodo sandbox, and there's a really nice piece of connection between Zenodo and GitHub that if you create a release, it automatically creates an archive on Zenodo, because Zenodo is an archive and it connects to GitHub. Once it's on Zenodo, you can delete your GitHub, but the Zenodo version still persists, right? And so this slide is right now on Zenodo because I've presented it to you guys. For me, that means it's public, and I put it into an archive. So in the time that's left, other than exhorting you to test and train yourself on how to actually deposit to these kinds of archives, let me go through a few special cases relatively quickly. So I haven't talked about it, but Jen talked about that earlier. What happens if you run your own survey? Okay, so key part of that, and Jen already mentioned that, be transparent. Okay, your questionnaires, your instructions to self, to survey takers, your sampling scheme, all of that is metadata. Now, there might be some pieces of information in there that are confidential that need to be edited out, but the rest of it should be transparent, accessible to people out there documenting it. You are your own data provider, just on par with the Census Bureau that publishes all sorts of data, right? So you are part of that data provenance chain, even if you're using it yourself, right? And so you're a data provider by putting the data out there, and now you need to think about that license, and you need to think about what you present the data as. You've collected survey data. Well, survey data is imperfect. It's people responding to queries, forms, etc. You might still want to do some data cleaning for your analysis, but the data that you post should be the raw data. You might have some best practices on how to clean it, but you should post the raw, confidentialized, de-identified, but otherwise statistically not manipulated data, because that's how it got collected. That's transparency, right? And then you should cite your own data source, right? If you run your own lab experiment, you are a data generator. And other than the fact that your forum takes a particular case and you're not out in the field, you're in a lab, you're generating data, you're providing stimuli, you're collecting the information that comes out of it. And everything I just said just applies exactly the same, except that now instead of a survey questionnaire, you're going to provide your programming for the experiment, right? What did you put out there? If you ran this on Amazon MTurk, what was the website you presented to the folks who did your tasks? Can you give us copies of that, screenshots, variants, the programming code behind it, all those kinds of things? That's the same kind of information that you get from survey collectors and the same kind of information that places like the Census Bureau publish about their surveys, right? Now, that edge case, what if you work in an RDC, a restricted access data environment? Now, this might be because you're working with the confidential survey data you collected, but it might also be in an environment where you got access to restricted access data, but it's not your environment to control. So you don't control storage backups, etc., and you can't just remove stuff from there, right? That does not prevent you from creating reproducible research, because within that bubble, you can do lots of stuff. You can create your own little GitHub, right? Set aside an area of your workspace for immutable copies of stuff. You might be able to rely on the data provider to keep an immutable copy of the data, but you can create snapshots of your code. And Git doesn't rely on GitHub. Git can be run locally, and you can version that way and create releases and do all the stuff I just mentioned as well behind a firewall that has no access to the internet. You can create releases every time you request removal of the code from that environment. Create a release, tag it, package it up, send it off to them. You are communicating with somebody external to your group. That's part of the release process. And then once it's been edited, vetted, and sent to you, create a mirror of those releases on the outside, possibly in a public sphere as on another GitHub, right? That mirrors all of these releases. And you can document what the access process is, not just the one that you got to access the data, but potentially also how others can access the data files you created that did not make it out of the environment, right? You might have created a particular clean version of a wonderful health survey, right? Others might want to reuse that. Think about the license thing, think about the description thing, make an archive within that, work with your data provider to say, if people come and knocking on your door and they get legitimate access to the source data, I have derived data that is much cleaner, and they should also get access to that. So all those things are possible, and all those things have been done, and we have guidance out there. So guidance, there's a few of us data editors out there, and so my European colleagues suggested we're a guild, sort of medieval thing. I did suggest that we have a slightly more modern logo than a bunch of stuffy white guys sitting around in a room with top hats. But we have a website. This is a pretty long URL, but the slides are out there, and so this is within the slides. And there's a lot of information on there. And so as I said, this is already archived. There's a DOI for that. But let me just very quickly, here's some of those extra resources. So we have a discussion of licensing, of data citation, and a few of the other things that we talked about. But I just wanted to have a brief mention on robust science and open data. So there is currently a discussion going on around EPA, which wants to limit what scientific studies can be taken into consideration for rules, such as what kind of pollutants to allow in rivers, etc. And one of their concerns is that, oh, open science requires open access data, so if the data is not open access, we can't use it. So how do you measure that there is an effect on the population when there is pollution? You get access to medical records, and those medical records are highly confidential. And so if that's the criterion, you can't do research that documents any type of pollution that affects people. In fact, you also can't test what certain products from manufacturers are, because now you're using proprietary products and you can't publish those either, right? But that's not a criterion for robust science, because we just talked about a few of the things on how you can get access. Jen mentioned that earlier as well. And one of the prime examples is actually in the federal government, where information from 5 agencies on health, on taxes, on wages, etc., is available to several hundred researchers who have a very lively debate about how to go about these things, etc. Right? And this is true worldwide. So it is certainly possible to do robust, reproducible, and replicable open and ethical science using restricted access data if the restricted access is for ethical reasons. It's not about somebody saying you can't get my data because I'm the holder of that. But if there are restrictions that requires people to walk into a locked room and to conduct research, it is feasible to share data within those locked environments, and it's feasible to describe every piece of that process out there. Now I'm done.